Hey, my name's Julian Faust. Welcome to the Profits and Panels podcast. Today I'm joined by Madison, the CEO of Space Copy. Madison, thanks so much for joining us and welcome to the show today.
Thank you so much, Julian. It's a pleasure to be here.
Of course, yeah. And I'd love to get started by learning a little bit more about your background. Can you share with us how you got started with Space Copy and your journey to where you are now today?
Yeah, absolutely. So, my story into manufacturing and aerospace is a bit unconventional. I was pioneering this idea for putting 3D printers into extreme environments yet back in 2017. But traditionally, my background is in business and commerce. I completed studies at Harvard Business School, and I'm actually just wrapping up an international business degree on the side. Apart from that, though, I had the privilege of working directly in the space field. So, I worked for NASA for about 6 years in areas like planetary science and astrophysics, mostly focused on things like dual use technology that benefits people on Earth and in space.
Do you do you guys target both Earth and space so there's a bit of a reason for you to actually run the company and make profits? Because sometimes I feel like people are concerned with spending money on space and maybe it's not the most useful thing as an argument. So do you guys target what's on Earth as well at the same time? What's the purpose of doing the dual use there?
Yeah, I appreciate that. And absolutely, we target ecosystems both on Earth and in space. If you're not in the space industry, that sounds like a pretty radical thing to say. But our manufacturing tech has applications across a myriad of ecosystems. So everything from energy to oil and gas, mining, construction, defense, and aerospace. We operate in a traverse of ecosystems, being able to create infrastructure in the places that you need it the most.
What's one example of what you guys are doing that maybe would make sense for people like, oh, I could see use for here on Earth and in space as well?
I think a good example of that would be 3D printing any kind of core infrastructure like pipes or bricks for housing or tiles that can be used for roadways or launch pads if you're looking for that dual use tech. We're able to 3D print structures that are super small, so everything from precision tooling, fabrication, and maintenance parts, all the way up to structures that are a meter in size. So everything that you can imagine across that ecosystem, we have a catalog of around 200 items that can be 3D printed. So whether you're operating on the International Space Station or the surface of the moon, underwater, or a natural disaster site, you are able to basically manufacture any kind of repair part, retrograde fit, or basic core infrastructure that you need to get the job done faster, quicker, cheaper, and better.
Yeah. So what's so special about your 3D manufacturing as compared to other companies? Is there some way that it can withstand certain weather changes, that sort of thing? Why is it effective for space and Earth?
Definitely. When we look at the way that we manufacture at Space Copy, we are non-traditional. And the way that the technology operates is essentially taking whatever raw material that you have on site and converting that into a usable feedstock for infrastructure. So everything from scrap metal to soil and sand, we're able to break it down on site and then do rapid manufacturing. We do all of that in a closed vacuum chamber. So regardless of the weather outside, it's not affecting the integrity of the 3D printer. And essentially what we can do is we have a system that detects different mineralogies. So if you're working with something that's metal based or you're working with something like sand that is more kind of ceramics based, our system is able to smart detect the different composition of materials and then adapt to manufacturing around different parameters and then around different weathering ecosystems. So with that in mind, it gives us a great deal of flexibility, not just in the material changeover process, but in the actual just kind of modular manufacturing unit itself. We have scalable models, so everything that could fit on the size of a table to things that are maybe more like 8 or 10 feet in diameter. So we have a pretty wide ecosystem of parts that can be printed and systems that can be deployed. It really just depends on your mission requirements.
Can you tell us a little bit about how you found a need for this, especially in space? How do you have those conversations and realize that this is actually a wanted thing and there's a use for it?
Yeah, so I think kind of when we go back in the storyline and we think about kind of the early days of Space Copy when we were just getting started, signing our first memorandums and LOIs, I had the opportunity to gain a lot of hands-on knowledge during my time at NASA when we were talking about the early days of the Artemis missions and sending humans back to space for long duration missions. And there was a critical technology gap report that was published in 2024 that talks about all the different technologies that are needed to be in space for long duration, the things that are circular, sustainable, and responsible. And manufacturing fell within the top 20 out of over 300 different technology pieces. We saw that call coming from government in other areas of the ecosystem as well. So the DoD was publishing additive manufacturing reports, talking about how logistics would be benefited from 3D printing. And then in parallel, we were seeing that same kind of appetite rising from your everyday companies. So folks in energy, folks in mining, folks still on the space side of the ecosystem. So getting to sit down with companies that produce rovers, for example. If something breaks down in space, they really have no method of maintaining their technology. So that can mean that millions of dollars worth of infrastructure is being sent up. When one thing breaks, the entire system gets shut down. And that is a really, really cost heavy approach to working in extreme ecosystems. So at Space Copy, when we started sitting down with these folks, whether it was in B2B or B2G settings, we were really looking at fundamental ways of how can we make this technology work smarter and how can we improve the lifespan of equipment in order to reduce cost while still maintaining that sustainability and recyclability in the core fundamental parts of our tech.
Okay, yeah. And I know you said you found a need, like people on Earth said they want this sort of thing. How did you find, what's been the most effective way for acquiring those businesses and people as clients?
I'd say at the end of the day, it really just comes down to networking and relationship building. So at Space Copy, we love to travel. We're always on the road. In the last 2 years alone, we did around 60 conferences, going to different trade shows. Some are more defense oriented, some are aviation, some are aerospace, and then connecting with people along all threads of that ecosystem, sitting down with them, trying to understand what are their pain points, what's holding them back, and then really just taking that ideation and iterating it on a little bit more of a technical basis, outputting a result. So going back to our lab, 3D printing something, making sure it works in line with the customer's requirement, and then actually sitting down with them over a meeting and just following up on that original engagement and saying, okay, we have a solution that could really, really benefit your industry. It could cut up to 70% of your logistics cost. It could produce parts at 20% faster than standard construction. What is the next phase in that collaborative agreement? And for us, a lot of the time that looks like bidding on contracts together with medium or larger size enterprises, or it looks like doing a pilot project, or just getting an agreement signed that says we want to be able to sit down with you a few times a year and listen to what your pain points are and try to manufacture a solution around it.
Out of curiosity, you say getting them to sign an agreement. Are you offering something to them to sign the agreement, or is it just like a non-verbal agreement saying, or a verbal agreement saying, we'll meet a couple times a year and find a solution to some problems you're having?
I'd say that we've approached it in both forums. So, a couple times verbal agreements that we do follow up on, but we are in the business of actually just getting down to the pen and paper, signing an agreement that says, we would print you off some 3D printed parts from whatever material that you have that you want to work with. If you're in the desert, we'll 3D print with sand. If you're underwater working on a submarine, we'll take scrap metal from a broken part and we will manufacture that legacy tool that no longer gets produced by the standard OEM manufacturer. We will be the guys that essentially kind of go out to the field and do the early stage manufacturing and field testing, and then just see if the concept is valid and it works for that specific use case. And from our end of the equation, that gives us a really good opportunity to get hands-on R&D experience and perfect our method, if you will. And in kind of the same line of that ecosystem gives the end user the opportunity to really assess, does this technology work for us? And are we looking for a longer term engagement?
I'd like to go back to what you were speaking about earlier with basically if one part in space breaks down, the whole entire ecosystem is just kind of paralyzed for the moment being. So are you guys basically offering to, with the 3D printers, you're solving whatever part breaks, you're able to build it on the spot, maybe within a couple days and have the ecosystem back up and running? Is that how that would work?
You absolutely nailed it. That is the value proposition of having 3D printers in space or any extreme environment for that matter. When we're looking at what is the exact use case, say a wrench needs to be 3D printed and a spare gear needs to be 3D printed to make a rover function on the surface of the moon or to repair a part on a moving satellite. We are able to deploy scalable size 3D printers. So if you need something that's really, really small, or if you need something that's really big in order to print that repair part, we can deploy according to your mission requirements and 3D print on site using, again, whatever material that you have. 3D print that part. Sometimes it takes a couple minutes, a couple hours, or at most a couple days. And then we have a system where we are doing kind of in situ real time quality assurance. We have a 5-axis automated robotic arm that's doing all of your post processing. So it's making sure that you have those tolerancing requirements and those standardizations that would meet the requirements of essentially being able to have an equivalent replacement part. And then we pass that off to the end user to reinstall into their hardware. And that can actually improve the longevity and lifespan of equipment by double or even triple its original estimation.
You said robotic arm, and then I heard the word end user as well. So do you have someone controlling a robotic arm to do the engineering and fixing? And then are there like engineering like astronauts out in space who are doing it themselves? What's that combination there look like, and how does it actually get installed after the part is manufactured?
Well, this is a conversation about automation and AI, so I'm really happy to say that this entire process is fully automated. So we develop out in-house custom machine learning systems, custom algorithms based on open API data. We integrate cybersecurity, of course, throughout all different stages of this ecosystem and all this process. And the way that it works essentially is we code up in advance with our custom software systems everything that we need to happen. So from the material processing side to the manufacturing to the post-processing and robotic enabled quality assurance. And we are able to essentially control the system from anywhere on the planet. It has its standardized commands to synchronize all the subsystems of hardware. It has the ability to detect errors, log them, and then operate around them. So again, regardless of the ecosystem, you might run into some challenges, but we have the ability to kind of work around that. And then to kind of close it off, you can have an astronaut or a trained user actually monitor the system, but it's not necessary in order to be able to power it, in order to be able to operate it. You can essentially just hit the start button or click start on your PC from wherever you are in the world. You could be operating it from space, right from the living room of your house, and then essentially carry out that manufacturing process. Now, if you have boots on the ground, but depending on where you are, if it's, the moon or if it's a combat zone, you might not have that luxury. So we've enabled that system to be automated in either case.
So when it comes to automating the repair part of it, is it exactly just, do you have like one tool that does it, or do you have multiple different kinds of robots for specific situations? What does that look like?
Yeah, so the way that it typically works from our end, we have one gigantic robotic arm located in the center of the 3D print chamber. And you can kind of see a rendering of that in my virtual background behind us. But that robotic arm has a suite of end effectors where essentially you can swap out whatever tool head you need. So if that is a gripper in order to actually grab the 3D printed part off of the build plate and then drop it into a collection bin for that end user, or if it is a saw or a scraping tool. If you're familiar with 3D printing, you know that you have to have support structures the more complex that your part gets. So being able to snap off those support structures and file down the surface of whatever you've just completed with the printing process allows you to kind of prevent any kind of significant flaws in delamination. And then while all of this is going on, we're doing a non-destructive quality assurance. So we use a type of spectral hardware that scans and identifies any kinds of voids, cracking, or porosity in the part. So again, you're meeting those tolerancing requirements. And we're working right now on becoming ISO certified so that we would be able to better service some of the ecosystems that we're already starting to deploy to.
When it comes to what would you say is the biggest challenge you guys face in the business? And when I ask this, I don't mean within the technical side, like a problem you're trying to solve and make it more efficient. On the business side, do you have trouble getting in contact with potential customers? Are you looking to grow at a faster pace that you aren't able to? Like, what's something that you want to solve on the business side to keep growing as you are?
I think because of the fact that we are an earlier stage company, being able to convince your audience that this is not science fiction, it's a fact, it's possible. We can put 3D printers into any kind of traverse ecosystem and manufacture infrastructure is a lot for people to wrap their mind around. So whether it is a customer or an investor, I think just kind of getting the message across and validating what we've done in the past as a preamble to what we're building in the future is really what's fundamental here. So we are preparing technology to go to space as early as 2026 and then landing something to the surface of the moon as early as 2031. And we are working with NASA to make it happen. We've won some contracts in the past. We're continuing to build up on that and then getting customer agreements signed with some of the smaller to medium scale businesses that already operate in that ecosystem. So if you're in that industry and you have a technical background, it might make a bit more sense to you. But if you're coming at this from a business background, you're a former hedge fund guy, that might not really connect the dots unless you're actually seeing it work in live time. And in order to make it work in live time, you have the catch 22, right? So you have to be able to fund it, you have to be able to have that client, and then you have to be able to deploy the tech. So from a business dev perspective, I think if there was one thing that we could improve on in the future is just really solidifying the message and then being able to validate that this tech works in all of these ecosystems with all of these raw materials, and that we're able to actually service those end users and actually make it happen as a validation key to allowing us to scale and grow faster.
I completely see the problem you're talking about, and this is sort of the thing with AI as well now, where everything's growing so fast, but at the same time, people don't always realize how fast it is. You have Google's video generator like VO3 that can make those incredible videos, and for people, like, that's one thing they can see. But then they also don't realize that like AI agents are already out there and existing because it's not like the most visible thing to you. You have people working on it, businesses already using it, but some people just aren't aware of it at the time. So just making people aware of that sort of thing and what's possible, I kind of see a connection between that and your business right now.
So, if I kind of go back and think about kind of my introduction to AI using LLMs, like the large language models, even as just a hobby, I was a skeptic at first. I did not understand how any of it worked. At that point, I was just experimenting to figure out if AI enabled tech would allow us to really, really connect to our hardware. And I think without kind of gaining that holistic hands-on approach, a lot of people kind of struggle to figure out the use case and the applications of this kind of technology into their everyday business. So picking up on that thought, everything that we experience at Space Copy, if it's doubts on the customer side or if it's doubts on the investor side, I think it kind of goes back to that same narrative, which is you only learn through experience. And we're having this paradigm shift in artificial intelligence. And now I see us having that same kind of paradigm shift in what we're building here at Space Copy.
Yeah. And sort of speaking on the topic of AI right now, how have you used it to get rid of repetitive tasks within your day? And maybe what haven't you done yet that you're looking to do in the future?
I mean, besides automating 3D printers to build houses on the moon, we also use that automation tool just in everyday life. So, being able to automate some of our email workflow, being able to carry out our internship program because we run interns twice per year. So, we're actually going through our summer cohort right now with 50 brilliant students. But having that many people on a team that's still relatively considered a small business can definitely run into some challenges. So, being able to use automation to get kind of the more menial and repetitive tasks done, and then being able to then focus our time as a team on maybe some of the more important stuff, like really dynamic conversations or business meetings or acquiring new customers or helping to train the new members of staff. That's kind of the area where I feel that automation helps us the most. And I think that's pretty commonplace. I think a lot of businesses are turning to AI for that kind of automation help just so that they can get through the day to day a little bit quicker. And for us, it has made a really, really big difference in what we're doing.
So you already started, like, where exactly have you used it in your day to day? Is it for email follow-ups, like these repetitive tasks that you've already done? Do you have a programmer within Space Copy who's doing that sort of thing for you guys?
Yeah, absolutely. I'd say it depends on which member of our staff that you're talking to. If you're talking to me, definitely email workflows are an area that I use automation in a lot. We do, of course, the kind of original engagement, but follow-ups, maybe scanning documentation as well. If it is a 40-page contract that comes across our desk, but we need to know kind of the basis takeaway of it before we really dive into the more complex subject matter, we can use automation there. And then I'd say just kind of in our executive suite, our chief strategy officer does a lot of work for integrating AI workflows into the core pieces of our technology. And then our business development lead uses automation for a lot of customer and investor outreach. And then we also have an intern program coordinator that's helping to kind of automate some of the workflow tasks for our interns and our early trainable staff, just so that we kind of have a good basis of what people need to know when they're going in to a project like Space Copy. And then we can actually really, really dedicate our time to sitting down and answering the important stuff.
Yeah, and I know before you were saying that it's a bit of a trouble not to gain trust with potential clients, but to make them aware of what's really possible with what Space Copy is doing. How are you guys using marketing channels over like the next year to two? Like, what are your plans there to improve them so people just are more aware of what you guys are doing?
Well, I think that the most important form of marketing is actually sitting down and having conversations with people. And it's a big reason that we spend a lot of our time on the road. So, actually being face to face with folks at trade shows and conferences, I think, is marketing in itself. But sitting down for conversations like this, being part of media publications and broadcasts and journalism papers, that we also publish a lot of research through people like ResearchGate or Science Direct or Elsevier. We kind of target different audiences. Being able to also post on a variety of different social media platforms like LinkedIn, Instagram, where we really have our core following, allows people to really just kind of follow on the journey. They might get to the idea in their head about cool 3D printers that build infrastructure in the craziest of different ecosystems, but then being able to kind of see it in a repetitive form, see us, 6 months later with an actual piece of hardware that's building in a laboratory, and then see us 6 months later again sending our first 3D printer out to the Arctic to start building infrastructure for an analog astronaut test site. These are all things that are part of our agenda and things that we try to reflect in our social media, so that you're seeing from the customer perspective, or even just from a person that's really, really interested and nerding out a little bit in the tech, if you will, how the journey has become. This started as a one person operation, and it has scaled and grown to just, like renderings, a couple of staff. Now it's more staff with an actual hardware. Now it's actually being able to get out there and start selling to consumers, fundraising, growing, scaling, and then getting out into more traverse ecosystems of deployment. So I'd say, just to kind of come back to that home message, when we are looking at getting the message out there, it's all about looking at that growth trajectory and seeing how we've expanded.
When it comes to growth, where do you guys see yourself in the next year? What's the next step for Space Copy?
Definitely a few things on the agenda. So first and foremost, we are fundraising. We are trying to raise about 5 million to keep scaling and growing out our 3D printer systems. So moving away from a handful of prototypes into something that's more scalable. Aside from that, we have on the technical side, being able to deploy the 3D printers into two ecosystems specifically. The first into cislunar space, so halfway to the moon and back, just get a feel for printing in a zero gravity environment and see if there's anything kind of fundamental that we should be on the lookout for that we're not already addressing. And then also being able to 3D print in the Arctic. Like I mentioned, the analog astronaut test base in the Canadian Arctic Circle, that is our next stop with the 3D printer that we are currently working on right now up in Canada. And I'd say aside from that, building more partnerships, getting more client assigned into the already ongoing list, and then just really sitting down with end users and saying, okay, what would make your life easier? So getting the news out there about what we're doing, spreading the word, getting more of an understanding of what people actually want, and then deploying the tech.
Madison, thank you so much for joining us today. Where can our audience find you online and learn more about Space Copy?
Yeah, absolutely. So if you are curious, you want to learn more about Space Copy, obviously the best place to go to would either be our socials or our official website. So official website, spacecopy.com, where you can follow at Space Copy on LinkedIn, at Space Copy Inc. on Instagram. And definitely don't be a stranger. If you're interested in manufacturing tech or you think it sounds cool to put 3D printers in space, definitely give us a shout.
Thank you, Madison.
Thank you.